of these for just three, four, a few bucks. These are little boards that are SMT component boards. You pretty much put your little part right here. You solder like a resistor or a capacitor right here. Then you plug in your wire and your wire. You solder those in. So this way you can connect diodes and all kinds of stuff on such a tiny form factor, surface mount style, and connect it to wire. And it's super cheap, 50 of these boards. I feel like that would be super useful. In fact, check this out. Let's say you stuck a socket into this set of pins, and then the other side of the socket into this set of pins, and now you solder in the socket. You could pop your microcontroller in between, so this board straddles the two sides of a dipped socket. You put your microcontroller in, and then you've got this whole pin out, and you can solder in going this way a capacitor for between two pins, or going this way a resistor. You can solder on a LED, and then bridge this, and then solder on a resistor for LED circuit for a flash blink program. I mean, you can do anything with these. But the idea is to be able to use surface mount components, which are really small. You can really shrink down your form factors here, as opposed to dip components, whenever you want, wherever you want, really quickly. Yeah, I think that's a very good analogy to electrical band-aids. That's kind of what they're doing here. Here's another one. So basically here, you would put a IC board that has 8 pins coming out of it. You'd solder that, a sit-on-top version of a circuit. And then this just gives you a breakout where you plug your wires, or you could plug header pins. And then you can put jumper wire into the header pins. You could put headers in it, or you could just solder wire directly. But it's a pin out, so you don't have to try to dead bug it or solder somehow to the teeth right off of here. It gives you the nice drilled hole to stick your wire in for a nice solid connection. And it's just a little board you can use wherever. I want lots of little boards like this so I can swap between dip and whatever. I like boards that have more than just this 8 pin out version too. This is incredible. It's like just making it possible to connect to all this tiny stuff with your wire in a simple way. Converting from surface mount to dip, just quick. Save time. You don't know what's out there unless you look. So I just typed in SMT into eBay and I'm just scrolling through every single listing. And I'm learning a lot. I'll know everything out there. It demystifies electronics when you know everything there is to know about all electronics. Stop listening. Look at this. If you Google dip adapter, dip simply means an electronic part that has holes drilled in it, and around those holes are copper bordering. You can stick a wire through and solder it into dip, or you can stick a component through that has little copper legs and then solder it into dip. So dip just means little holes in your board. SMT means surface mount. So you can see dip here with the holes, and then you see little copper traces leading to a SMT area where some part can be soldered on that has 3 little arms coming off it. So a 3-armed part that's tiny. You guys have to realize this is under a microscope. A tiny 3-armed part forks out into 3 little holes. Now those holes you can solder wire into, and now you're good to go. Or you can stick header pins into it and then plug jumper wire into the headers. Or have female jumper wire plug into male header pins. Either way. This is just a way to convert loose wiring into, oops, we got to put some kind of part, and then, oops, go back to loose wiring again. It's just a way to jump from loose, free-floating wire to a board and then back to wire again. And that's nice for a robot, because a robot is mainly just wiring, and I don't want a bunch of big circuit boards hanging out which have a set form factor. I need to have free-floating circuit boards throughout the robot, and this would enable that. I could have a little potentiometer mounted on here that's too small to solder wires to directly, but you solder the little wire onto the mini board, or the little part, the little potentiometer, the little diode, whatever it is, onto your mini board, and then you solder the wires into the board. You don't even have to solder the wires into the board. You can use a crimp fitting to put a male or female header pin onto the wire, and then plug your little headers into these and solder them in, so the wires can be pulled out or plugged back in with no soldering needed. And that saves time, and it prevents a possible solder joint failure. Solder joints, when you bend them back and forth, eventually they break. Whereas crimp fittings don't break because there's nothing soldered. It's not weakening the structural integrity of the free-floating wires. So all kinds of little boards like this I'm very interested in, especially when you can buy them $50, 50 boards for $2. It's like amazing tool. I thought about just having wires soldered directly to dip components, which is still possible, but I'm already seeing from experience that there's a high likelihood of that wire bending back and forth and eventually breaking. The soldered joint makes the wire brittle, where the solder joint meets the flex wiring. I really like the idea of using surface mount components and miniature circuit boards to make everything way smaller with no form factor constraints as you would get with a large printed circuit board creating your whole circuit, and then you have to somehow fit that form factor into whatever you're doing, into your robot hand, into your prosthetic, into your robot seagull, whatever it is. This gives a lot of freedom and flexibility. Oh! Check this out, guys. So you stick a 3-pin diode or transistor, surface mount style diode or transistor, onto here, solder it down, and now you can fork that out to wires or a header. So you could have a free-floating transistor or diode wherever in a robot, anywhere you want. Next to a motor, for example, or wherever, and you just got your wires just can come into it and come out of it, just boom, right there. That's amazing. Gotta have it, man. This brings the electronics way smaller without any penalty or struggle. That is awesome. Smiling, I openly admitted that number one, I need to have an inventory of parts and know what they are, know what parts I have to choose from, know what is available. I don't like being mystified by just lack of knowledge. So I want to have a nice spread of different types of parts that are very multi-purpose to expand my capabilities greatly. This enables me to do really small component level stuff without having to buy a dev board. You can just buy a chip and just go directly from this type of thing. It's amazing. It's only $1 here or there for these types of things. You know, for 20 bucks I get a taste of it all. And this will greatly expand my capabilities. And when I say capabilities, I'm referring to getting things really small and being able to do that on a one-off type basis. And also, you know, I'm going to need this type of stuff for creating my robot for sure. I'm going to be using this. No, it's not just going around to the bucket. This is actually stuff that I know I will need for my robot seagull project. I'm sorry for you guys who love the robot crab idea, but I'm leaning toward a robot seagull instead of a robot crab so that it can fly home. The robot seagull will have a metal detector and it will search for valuables in the beach sand, and then it will fly around and it can fly home. Robot crab would get caught by somebody, they chase it. Robot seagull could just fly away. You know, I visualized little boards that could do this, but I didn't think they existed and I couldn't find anything. I just kept Googling tiniest form factor Arduino. I didn't know to look for these little dip adapter boards. I didn't know to search for that. I just knew something like this would be nice. To be able to tap into a microcontroller directly at a tiny scale without all the peripheries. Without all the fancy mumbo jumbo. Look at this, guys. There's so much crazy stuff. Look at this one. So this will take any Um, mic or integrated circuit or microcontroller of various different closenesses of pinouts and adapt it. So from the smallest, bigger, 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 different types of closenesses, and it will adapt it outward all the way until you get to dip. So then you can stick your header pins in and then plug your wires in. It's just amazing. What a useful thing. But I'm not going to buy it. That one's a little too general, I think. Take my chances without it. But each thing I buy like that is preparing me for a possible situation in the future where I'll need to use something, but I don't have the ability to do it because it's just too small. Ooh. See, I like this one a lot. Have you guys ever taken apart a laptop or whatever and seen the ribbon cables it has? The kind that you have to snap in, the kind that like goes from the laptop to the Wi-Fi card of the laptop. You can use ribbon cables like that to transmit information between one device and another. So one device could just output everything to these wire slots with jumper wires from a microcontroller or whatever, and then you plug your ribbon cables into here, and then you can send that for whatever distance you want a long way through your robot or whatever through the ribbon cables, and then end up on the other side with another ribbon cable, and then fork it back out. That, as opposed to sending all these wires out, you'd be sending a ribbon cable out, which is just neater and better wire management. It's just really cool. You could also interface your hand soldered stuff to your laptop through ribbon cable this way as well. If you could figure out how all that would work, I guess. That's the hard part. But it's just these boards that break out something so tiny that you just are like, I don't even know what to do with this. I have to use a microscope to even see what I'm looking at. But then it breaks it out, it splays it out so that you can actually solder wire into it. Now you're tapped in, now you can do stuff. That's the idea behind these dip converter boards. They make something that's too small to even deal with become very accessible for even a child. To be able to use these tiny micro components and micro connection interfaces and make them big and usable.